In this topic, we are going to cover interfacing with the Windows API. Before we jump straight in and start using the Win32 API, it's important to know that the Win32 API will often have both ANSI and Unicode versions of a function. The Unicode version has a W appended to the name, while the ANSI version has an A appended to the name. When working with buffers and argument types, make sure that you are using the types appropriate for the function you are trying to use. With that said, let's import from C types as well as importing some other Windows specific types to make our work a bit easier. We can save this. And with these imports out of the way, let's take a look at the Win32 API version of Hello World by interfacing with the MessageBox-A function. So let's first find this function on MSDN. And so here we can see the definition of the function. MessageBox-A displays a modal dialog box that contains a system icon, a set of buttons, and a brief application-specific message, such as status or error information. And here we can also see the function definition, as well as the expected parameters. So the first parameter is a handle to the owner window of the message box to be created. If this parameter is null, the message box has no owner window. The second parameter is the message to be displayed. The third parameter is the dialog box's title. And the fourth parameter defines the contents and behavior of the dialog box. And in order to make use of this function, we need to know its location and its function prototype definition. And a function prototype definition just describes how a function works. So the prototype includes the return type, arguments, argument types, and calling conventions, without including an implementation. We don't need to implement MessageBox-A because somebody has already done that. We just want to call it. So let's set up our prototype, MessageBox-A, and we need to know where we can find this definition. And so here we can see that MessageBox-A is defined in user32.dll. Next, we need to define the argument types for this function. Which we can see here. So we need a handle. We need LPC str, and uint. We also need to define the return type. And we can see here the return value is an int. We can print this out. And here we can see we have a function pointer object at this address. And so now the message box foreign function can be called. So we need to know the values for these parameters. So we can specify our LP text, which can be world, our LP caption, which can be hello, and we also need our type. And copy this code here, MB, OK. And now we can call message box A with these parameters. And remember that if we specify null or none, the message box has no owner. We can execute this. And here we can see that from Python, we've interfaced with the Win32 API to call the message box A function. And here we can see we have the MB OK option. However, we might instead want to say OK cancel. So we can use this code here. And execute this again. And now we can see that in the pop-up, we have the option to click OK or cancel. And this is quite a straightforward function call. We just call the function and didn't need to really do anything or interface with the data which was passed. But what if the API call was doing something and we wanted to know the outcome? For the most part, in our lessons so far, we have achieved this using return values. We would return the value from the function. But functions in the Win32 API can also work based on a reference. So for example, we can take a look at the getUsernameA function on MSDN. And we can see that this function retrieves the name of the user associated with the current thread. And we can see the function definition here, as well as the parameters. And the first parameter is a pointer to the buffer to receive the user's logon name. And the second parameter specifies the size of the LP buffer. And we also have a return value. If the function succeeds, the return value is a non-zero value. However, this return value isn't going to be the name of the user associated with the current thread. That information will instead be stored in this LP buffer. So let's demonstrate using this function as well. Let's first comment out this message box. We need to know where this function is defined. In this DLL, get username A, the arguments, LPSTR, LPDword, and the return type, which we know is an int. And now we need to know how to interface with this function. So let's first specify the size of our buffer. And a dword is just a 32-bit unsigned integer. And now we can also create our buffer based on the size of our buffer. And now we can call our function. And we use by ref here because LP dword is a pointer to a dword. Now that the function has been called, we can print out the value. So let's execute this. And here we can see newtr has been placed into the buffer as expected. And if we don't give enough space for our buffer, we can see that something has gone wrong and we no longer have newtr as a result. And ctypes uses Win32 structured exception handling to prevent crashes. But we can also make use of the getLastError function. And this function returns the last error code set by Windows in the calling thread. So if there is an error or problem with our API call, we can make use of getLastError for debugging. So for example, we could get our error code here. And we know from our function definition that if the function fails, the return value is 0. And here we're also being told to get extended error information, call getLastError. So if we have an error, we can print that error out. And so here we can see we have an error code of 122 when we're using a buffer of size 2. And if we use a buffer of size 8, we don't have an error anymore, and we can instead see the expected output. And so now that we have an error code, we can identify what this means. MSDN error codes. And here we can see on MSDN, the following list describes system error codes, error 0 to 499, and our error code was 122. And here we can see the error code corresponds with the error that the data area passed to a system call is too small, which is correct because our username can't fit within this buffer. However, this is not a very efficient way to perform debugging. So what we can also do, we can print out the Windows error message for this error code. And here we can see the same output. The data area passed to a system call is too small. So this is how we can use the Win32 API with basic Windows data types. And we will also go over some more hacker-focused API calls later in this course. But what if we also need to make use of Windows-specific structures? So for example, let's take a look at the Win32 API call getWindowRect. And we can see that this function retrieves the dimensions of the bounding rectangle of the specified window. And the dimensions are given in screen coordinates that are relative to the upper left corner of the screen. And here we can see the function definition for getWindowRect, and it expects a handle to the window as well as a pointer to a rect structure. But how can we use this rect structure in Python? Well, we can rely on C types for this specific case, but let's use this as an opportunity to define the structure ourselves. So we can recreate this structure. So let's create a rect structure. We need to define our fields. And the fields are left, which is along. We also have top, which is along. We have right, which is along. And bottom. And now that we have our structure defined, we can use it. And we can print out the left item, the top, the right, and the bottom. And currently, for our rectangle, left, top, right, and bottom are all set to 0. However, we can see that we can change this. And so now that we have our rect structure, we can also use the getWindowRect function. So let's define this. get window rect from user32 again. We can specify the archetypes. Which are a handle and a pointer to a rect structure. Also need the return type, which is a Boolean. And now, in order to use this function, we need to pass in a handle to the window as well as our rect structure. But what about the handle? A handle is an abstract reference value to specific system resources. So for example, a memory region or an open file. And we can make use of get foreground window, which is again another Windows 32 API function. And this function retrieves a handle to the foreground window. So we can specify our handle from user32. So we can call this function directly. Then we can use our get window rect function. We pass in our handle and we pass in our rect by reference. And after running this, we can print out the left, top, right, and bottom components of our rectangle. Let's execute this. Let's fix this error here. And now we can see that our rectangle now contains the dimensions of our window. So if we change our dimensions and rerun this, we can see that the output changes because the size of our window has also changed. And having access to the Win32 API as a hacker enables us to make use of a number of really useful and important Windows functions. And it also means we don't always need to hack together our own custom solutions for problems in Python either. We can instead just interface with the Win32 API. But that's it for now. And in the next lesson, we are going to cover undocumented API calls.